Hello everyone, this is January 2023 IGCSE paper 1. Okay, so let's have a look at this first question. So question 1, it says 80 students entered a dancing competition. The table gives the information about the length in minutes for which each student spent dancing. So again, a very common early question on an IGCSE paper, or indeed GCSE paper for that matter. What we need to do here is find the midpoint times the frequency, add them all up and divide them by the total frequency. So the midpoint from 0 to 12 is going to be 6. The midpoint from 12 to 24 is going to be 18. The midpoint from 24 to 36 is going to be 30, and so on. So we do the midpoint times the frequency. That's right here, MP for midpoint times by the frequency. That gives us all of these values. We add them up, and the mean is that total divided by the total frequency, which is 80. So that gives us a mean of 27 for question 1. Question 2. Solve 3 times by 2 minus 4x equals 5 minus 8x. So step 1 has to be to expand the brackets. So we're going to expand the brackets. So 3 times 2 is 6, and 3 times minus 4 is minus 12. Then the next thing is to get everything over one side. Now I've taken the 5 over to the left, so 6 minus 5, and I've added the 12 over to the right, so 12 minus 8. 5 minus 6 is 1, and 12 take away 8 is 4. You divide by 4, so x is equal to 1/4 there for question 2. Question 3. Use a ruler and compasses only to construct the perpendicular bisector of the line AB. You must show all of your construction lines. So what we do here is we take a compass and you set it to anywhere that is over half the length of the line. It really doesn't matter how far it is, but what does matter is it has to be over half. So you draw an arc there, like that. Keeping the compass the same, you then take the compass and put the point on the other end of the line. Draw another arc, like so. So we've drawn our 2 arcs. Now we take a ruler and we basically just draw a line going through the 2 points where their lines cross over. And that is our perpendicular bisector. And I've put a little right angle on there to show that it's perpendicular as well. Question 4. It says the diagram shows a pentagon. Okay, work out the value of x. Now, the interior angle sum is n minus 2 times by 180. So all of the angles in this particular shape, this pentagon, are going to be 5 take away 2, because the number of sides is 5, times 180. So that means that all of the angles inside that pentagon add up to make 540. So now we just write down that all of the angles have to add up to make 540. So we've got 119 add 67, add 135, add 90, add x, all must add up to make 540. So for x is going to be, we're going to take away all those angles. So that gives us 129 degrees is our answer to question 4. Next one, question 5. In a box, it says there are only green sweets, orange sweets, and yellow sweets. There are 280 sweets in the box altogether. Okay. The number of green sweets to the ratio of number of orange sweets is in the ratio 2 to 3. So green to orange is in the ratio 2 to 3. The number of orange to the number of yellow, orange to yellow, is 1 to 5. Okay. Work out how many green sweets there are in the box. Now, for this kind of issue, this kind of like 2 separate ratios, what we need to do is we need to make these two have the same one in the middle. Okay. So in order to do that, we need to times both sides of this ratio by 3 so that we have a 3 matching in the one that's common. So we leave that ratio alone, so that goes 2 to 3, but this ratio we times both sides by 3 so that we've got a matching 3 there in the middle. And 3 times 5 is 15, so the ratio of green to orange to yellow overall is 2 to 3 to 15. So now what we need to do is to work out how many green sweets there are. We just need to divide the 280 sweets in this ratio. So we add 2, add 3, add 15 gives us 20. 280 divided by 20 is 14. So we times each of those ratios by 14 to find out how many sweets there are of each colour. And 2 times 14 is 28. So there are 28 green sweets. Question 6. Shane bought a car. The amount that Shane paid for the car was $32,000. Teresa also bought a car. To pay for the car, Teresa paid a deposit of $18,000 together with 14 easy monthly payments of $1,160. Teresa paid more for her car than Shane paid for his car. Work out how much more Teresa paid as a percentage of the amount that Shane paid. So first of all, let's see how much did Teresa pay for her car. So she paid $18,000 plus 14 installments of $1,160. Okay, so we do 14 times 1160 is 16,240. Add on the 18,000, that comes to 34,240. So Teresa paid 34,240. Shane paid 32,000. So Teresa paid $2,240 more for her car. Now we've got to work that out as a percentage of how much Shane paid. So we work out this amount here, 2240, divided by the amount that Shane paid, and we times that by 100. So basically, Teresa paid 7% more, okay, as a percentage of how much Shane paid. And that's how we would work out question 6. Oh, there's another part. Kyle bought a van. After 1 year, the value of the van was $39,865. During the year, the van had decreased by 15%. Work out the value of the van when Kyle first bought it. So we basically don't know how much the van cost when we bought it, but we do know that it depreciated by 15%. Now the multiplier for something decreasing by 15% is 0.85. So we've got x times by 0.85 equals 39,865. So in order to get back to the original cost, we need to divide by the 0.85. And when we do that, we find out that the original price of Kyle's van was $46,900. Okay, very good. Next one. Some members of a library were asked to name the type of book that they each like to read best. One of the members is chosen at random. The table shows the information about the probability of the type of book that this member answered. So we've got comedy and romance are 0.24 and 0.4 respectively. Mystery is 3x and thriller is x. Now the first thing we must observe in this kind of question is that all of the probabilities have to add up to make 1. So we can use this information in order to be able to work out what x is. So we have 2.40 add 0.40, add 3x add x equals 1. So those two added together makes 0.64, and 3x add x is 4x. So now we take off 0.64 off both sides. So we get that 4x is equal to 0.36. And then we divide that by 4, so we get x is equal to 0.09. So now we can complete our table with our probabilities, because we know that this one is 3x, and we know that that one is x, okay? So therefore, 3 times by 0.09 is 0.27, and 3 times, just x itself is just 0.09. So we've completed our table there. Okay, perfect. Now, what does the question go on to ask us? The question goes on to ask us the following. It says 48 members answered comedy books. Work out how many members answered mystery books. Now, we know that 48 corresponds to a probability of 0.24. So if we want to find out what 1 corresponded to, what we need to do is do 48 divided by 0.24 in order to get back to the whole, yeah? Because 0.24 of the whole is 48. So we do 48 divided by 0.24, and that means that there must have been 200 books in total. So if there were 200 books in total, then the number of people who like mystery is going to be 200 times the probability for mystery. So 200 times 0.27. So that is how many of the members, it's not 54 books, it's 54 members. So 54 of the members most liked mystery books. So that is how we would do question 7. Question 8, let's have a look at question 8. The diagram shows a triangle ABC inside a semicircle. A and B and C are points on the semicircle. AB is the diameter. And we've got these angles that are shown. 50 degrees, that is 90 degrees, and we're told that that length is 18. We have to work out the perimeter of the whole shape. Well, the first thing then is we could really do with knowing what the length AB is, the diameter. And because we've got a right angle triangle, we could do SOHCAHTOA. So we're going to label the sides in order to work out the hypotenuse. So we've got this side here. If we're going from this side, then that side is our adjacent, that side is our opposite, and that side is our hypotenuse. We've got the cosine, we've got the adjacent rather, and we're trying to find the hypotenuse. So we're going to use this one, cosine, because it's to do with adjacent and hypotenuse. So we now sub in the information. So cos of 50 is equal to the adjacent over the hypotenuse. And then remember, when you've got these divided like this, you can swap these two over. So that means that h is equal to 18 over cos 50. And we work that out, that gives us that h is equal to 28 centimeters. So 28.00 centimeters. That's great. So far we found the length of the diameter. So now all we've got to do is we've got to work out the circumference of half of a circle. Okay, so what we're going to do with a semicircle. So circumference is pi times diameter. We now know the diameter is 28. So pi times 28 gives us 87.974. So the semicircle, perimeter of the semicircle, is that going to be divided by 2. So 43.987 is the perimeter of the semicircle. And then all we've got to do to that is to add on to the semicircle the diameter, and we've got the perimeter of the whole shape. And the diameter we found was 28. So when we add those together, that gives us 91.987. We're asked to give our answer correct to 2 significant figures. So that's going to be 72 correct to 2 significant figures. Okay, question 9. Oh, where is question 9? Oh, that's an interesting one. Maybe I missed it out. Yeah, maybe I skipped that one when I was going through it. Okay, well, let's do question 9 then. Here we go. Question 9. It says write 6.25 times 10 to the minus 4 as an ordinary number. So question 9, 6.25 times by 10 to the minus 4 as an ordinary number. So for these ones, I like to put a bunch of zeros in front of the number. And we're going to move the decimal point 4 places to the left. So 1, 2, 3, 4. So that's going to be 0.000624 is going to be our answer as a regular number. Okay. Now the next one, work out 2.4 times 10 to the 12 divided by 6.9 times 10 to the 4. Okay, so let's have a look at that. Let's write that down. So we've got 2.4 times by 10 to the 12 divided by 9.6 times by 10 to the 4. Now, because these are all times together, this can be thought of as 2.4 divided by 9.6 times by 10 to the 12 over 10 to the 4. So we can break that down in that way. And 2.4 divided by 9.6 is a quarter. That's kind of useful. So let's write that as a decimal, 0.25. And this is going to be 10 to the 12 minus 4. So we've got 0.25 times by 10 to the power of 8. Now, we need to make this into standard form because the number at the beginning of standard form has to be greater than 1 but less than 9. So the decimal point is going to go one place to the right. So it's going to be 2.5 times 10 to the power of 7. Because remember, when we go to the right, the powers go down, and when we go to the left, the powers go up. So that's going to be 2.5 times 10 to the 7 for 9 part B. That's part B, that's part A. Okay, now it is time for question 10 now. Question 10. Factorise y squared minus 2y minus 48. So we're looking for two numbers that times together to make minus 48, but add together to make minus 2. So let's have a think about what that could be. So we think about our factor pairs. So 6 8's 48. So 6 times minus 8 would make minus 48. And minus 8 add 6 would make minus 2 as well. So minus 8 add 6. So that seems to be correct. And all we have to do with these particular factorizing ones is just experiment with different kind of like possible factor pairings. So, you know, you might start, for example, with like 2 and 12 and think about whether that would work. But eventually you would get to this combination here. Okay, part B, write down the inequality shown on the number line. So first of all, we need to notice we've got a coloured in dot. When you have a coloured in dot, it means that you have a less than or equal to or a greater than or equal to symbol. When it's not coloured in, it just means it's either less than or greater than. It's pointing to the left, so it means that x is going to be less than or equal to 3. Okay, that's part B. Now part C, question 10, part C. Solve that inequality. Okay, so we're going to solve it just like we would solve a normal equation to start off with. I've chosen to take 7w off both sides, leaving me with 6 is greater than 5w add 14, because 12 take away 7 is 5. I've now subtracted 14 off both sides, so 6 take away 14 is minus 8, so minus 8 is greater than 5w, and then finally I just need to divide by 5. So I would end up with this, minus 8 over 5 is greater than w. But ordinarily, we would write it just that way around. I don't think it's necessarily incorrect to write it that way around, but it's better just to change the way that you write the direction. So that's the answer for question 10, part C. Now, this one, question 11, I thought was a little bit tricky, okay? So it says the region R is shown shaded in the diagram and is bounded by all of those various straight lines. Write down the three inequalities that define R. And what I think is tricky about this one as well is it's only worth 3 marks. So the way that helped me to understand this one was to rewrite all of the equations that were given in the question in the form y equals mx plus c, just so we could kind of like see what was going on with them. So let me show you what I mean. So first of all, the equation in the question, 2x add y is 6. So I just subtracted 2x off both sides, and I could see that I've got y is equal to minus 2x add 6. So I looked across at the question in order to see which line would match that, okay? So here we go, and you can see that this line here that I'm indicating there, that's the line that matches y equals minus 2x add 6, because it goes through 6, and as you can see, it has a gradient of minus 2, because for every 1 it goes across, it goes down 2. And the region R is below that, which means the y values are less than the 2x minus 6. So the region R is where y is less than or equal to 2x minus 6. Notice it's less than or equal to because we have a solid line. Remember, when we have a less than, or indeed a greater than, we have a dotted line. But here we have a solid line, so it's going to be less than or equal to, because the y values are less than the line in the shaded region R. So then all I did is just then finally rearrange it back into the format of the question, okay? So that means that I've got 2x add y is less than or equal to 6. So I started off with that, changed it into y equals mx plus c, got my inequality, and then rearranged it back into the format that it should have been. Okay, that's the first line done. Now, the next line, 2y equals 5x add 1. So here I divided by y, and that gave me y was equal to 5 over 2x add a half. I looked and see which line that's going to correspond to. We've got a positive gradient, and we're going through a half, okay? So that looks like it's going to be this line that I'm now indicating here, because we're going through a half and we've got a positive gradient. And you can see that the region R is where the y values are less, the y values are below the line. So y is less than or equal to 5 over 2x add a half. And then finally, just like I did last time, I rearranged it back into the original format. So the inequality for this one is 2y is less than or equal to 5x add 1. Nearly done now, just the last line, okay? And the last line, I mean, I've rearranged it still to make it in the form y equals mx plus c. Yeah, I think we have to do that so we can see what's going on with it. So step 1, I subtracted 2x off both sides. And then step 2, I divided by 3. So I've got it written in the form y is equal to mx plus c. We're talking about the third line here, the one we haven't used. And we can see that in the region R, the y values are above the line. So that means the y values are greater than or equal to the values on the line. And then finally, I just rearranged it back into the original format again, and I did that by timesing by 3 and adding on 2x. So I found out that I've got 3y add 2x is greater than or equal to 4. And that's how I would answer that question. But in my opinion, that was a tough 3 marks to get, and I wouldn't be surprised at all if most people didn't successfully get that. Tricky question. Question 12, we're getting there now through the paper. Let's have a look at the next one, question 12. So question 12 says 3 to the half times by 3 to the 2/5 is equal to m. Work out the value of m. So first of all, what have I done? Well, when you multiply two numbers, you add the powers together, okay? So we're going to have a half add 2/5. Now, in order to add two fractions, you need to have a common denominator. So I've multiplied the numerator and denominator of this one by 5, and the numerator and denominator of this one by 2. So they've both got a common denominator of 10. Then I have 5 over 10 add 4 over 10, which is 9 over 10. So the value of m is 9 over 10 for part A. Part B, we've got 5 to the power of minus 10 divided by 5 to the minus 4. Now, when you have a to the m over a to the n, that's the same as a to the m minus n. So that's the law of surds, indices we're going to be using. So we've got our 5 to the minus 10 divided by 5 to the minus 4. So it's that power, take away that power. Now this is where you have to be careful. Two minuses come together to make a plus. So we have minus 10 add 4, and that gives us minus 6 is our value of n. So that's question 12. Question 13, nice little one here for 3 marks. Expand that. Now that's really nice. So first of all, we expand 2x minus 5 all squared. And remember, this means 2x minus 5 times by 2x minus 5. So we're going to go that one times that one is 4x squared. That one times that one is 2 times minus 5 is minus 10. That one times that one is minus 5 times 2, which is also minus 10x. And that one times that one is a minus times a minus is a plus. Next step, we collect like terms. 4x squared minus 10x squared minus 10x squared is minus 20x. I'm so sorry, 4x squared minus 10x is minus 20x. And then we've got the plus 25, so we've simplified there. Finally, we just expand the bracket. So 3x times 4x squared is 12x cubed. 3x times minus 20x is minus 60x squared. And 3x times 25 is plus 75x. And that's our answer for question 13. Okay, question 14. It says the table of values of y is equal to that. Okay, and it wants us to fill in the table. So first, the first blank is we've got 0.5. So we've got 2 over 0.5 times by 5 minus 1 over 0.5. And 2 divided by a half is the same as 2 times by 2. So that's going to be 4. And 5 minus a half is the same. 5 minus 1 over a half is the same as 5 minus 2. So that's 3. So it's going to be 4 times 3. So that value is going to be 12 there. Okay. Let's now do the 2. So when x is 2, we're going to have 2 over 2 minus 5 times by 5 minus 1 over 2. So 2 over 2 is 1, and 5 minus a half is 9 over 2. So that's going to be 4.5. So the missing values there are 12 and 4.5. And if we sketch that, I think I have a little sketch of it here. Yeah, I used the good old Desmos graphing calculator to draw a little sketch of it. And that's what it looks like when you sketch it. Okay, and we're just interested in this bit here, the positive bit. So when you plot it on your graph, you're going to find out that you get a positive bit there. So you just basically plot those values on the graph for that next bit. Okay, next question, question 15. It says here are 9 cards. Each card has either a number on it or a letter on it. Thomas is playing a game. Thomas takes at random one of the cards and he keeps it. Be careful, Thomas keeps it. Thomas then takes at random another card and he keeps it. Complete the tree diagram. So first of all, let's have a think about how many numbers and how many letters we've got. So let's look at our letters. 1, 2, 3, 4, 5, 6, 7 letters. Okay, so there are 7 letters and we've got 2 numbers, a 7 and a 5. So when Thomas reaches in to select a card, the probability that he selects a number is 2 out of 9, and the probability that Thomas selects a letter is 7 out of 9. Now Thomas keeps the card that he selects, so this is conditional probability. So the probability now when Thomas reaches in the second time, if he'd selected a number, there's only 1 that's got a number in left now. And because he's already taken a card away, there are only 8 cards. So if Thomas selected a number first time, the probability of him selecting a number on the second time is going to be 1/8. Okay. And if that's 1/8, then the letter must be 7/8 because this branch needs to add up to make 1. Now let's say Thomas selected a letter first time, that's going to be 7 out of 9. When Thomas goes in to reach to select a letter on the second occasion, there will now only be 6 letters in there and there'll only be 8 cards. So that will be 6 over 8, which means this must be 2 over 8 because this branch has to add up to make 1. So that's our tree diagram completed for 2 marks. Now it says work out the probability that each of the 2 cards has a number on it. So that's the probability of number and number. Now when you think about when you have to think about that word and, you must multiply. So that they both have a number on them is probability of number and number. So that's going to be 2 over 9 times by 1 over 8, which is 2 over 72, which we could simplify into 1 over 36. Okay, and then the next bit, part C, work out the probability that there will be 1 card with a number on and 1 card with a letter. So there's 2 ways that can happen. Either we pick a number first and then a letter, so we can have that branch, or we pick a letter first and then a number. Now, when we hear the word or in probability, that means we need to add, okay? So let me just describe that in probability language. We can have a number and a letter, okay? So that's going to be times. So that's going to be number and letter is probability of number times probability of letter. Or, okay, we can have letter and number. Okay, so because I said or, I've put a plus symbol there. And letter and number is 7 over 9 times 2 over 8. So that's what we've got to work out. Those 2 fractions, and we add them together. And that gives us 28 over 72, which simplifies into 7 over 18. So that's our answer for that one, 7 over 18. Good, 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 good. 7/18. Okay, perfect. Right, next question. What have we got here? Oh, this looks intriguing. Little sort of bow tie type shape. Okay, so here we go. Here is a shape formed from two triangles, ABC and CDE. They give us all that information about the various lengths, and it's all labeled on the diagram there. We've got to work out the length of DE. So the ultimate aim of this question is to work out this length here, DE. So let's first of all deal with this first triangle, okay? Well, no, actually, let me look at the second triangle. Now, when I look at that second triangle there, I'm thinking to myself, if I knew what that angle was, I could use the cosine rule, okay? Because one of the formats for the cosine rule is when you've got two sides and an angle in between, you can find a side opposite. So if I knew that angle, I could use the cosine rule to find DE. So that's my first thought. My second thought is these are straight lines, the question tells us, which means that these two angles are vertically opposite. And vertically opposite angles are equal. So I can say that that must also be x. Okay, so now I'm going to turn my attention to the first triangle to see how I can work out x. I've noticed that I've got an angle and a matching side. So I'm thinking to myself, this could be the sine rule, because the sine rule is all about matching pairs. We've got a matching pair here of a side and an angle. And actually, we could use that to calculate this angle here, because we know the 24, but we're missing that angle. So the sine rule could be used to calculate that angle y. Now you might be thinking to yourself, well, why on earth would we need to do that? But if we know what this angle is, then we can use the fact that angles in a triangle add to make 180 to find out our x. So we now need to use the sine rule to find out this angle up here at B. So let's see. Using that version of the sine rule, it's going to be sine 64 over 31, so that one over that one, is equal to sine of y over 24. So we just rearrange this now by multiplying both sides by 24. So that gives us sine y is equal to 64 over 31 times 24, which is 0.69584. We do inverse sine. So here I've done y is equal to sine to the minus 1 of 0.6958. Okay, and that's, remember, where you use the shift button on your calculator. So that gives me that the angle y is 44.094 degrees. Perfect. Again, we're now going to use the fact that the angles in a triangle add to make 180. So in other words, 180 take away 64 take away y is going to give us x. So 180 take away 64 take away the y that we've just found is going to give us our x, which is 71.906 degrees. So now we can come back to the second triangle, and this one here is our 71.906 degrees. So we can now use the cosine rule in order to finish this question off. How many marks is this? Oh, it's worth 5 marks. So a good number of marks for this question. So using the cosine rule, now remember, when you're using the cosine rule, it doesn't matter which side you call B and which side you call C, but the side that you're trying to find must be called A. So we can say that this side here, DE, because remember we're comparing it with A squared equals B squared add C squared minus 2BC cos A. And for IGCSE, you're given that in the front of the formula booklet. So A squared, this one must be the A, okay? The A must be the one that's opposite the angle. So DE squared that we're trying to find is equal to 16 squared add 19 squared. And as I said, it doesn't matter at all which one of those you call A and which one you call B. That really doesn't matter. So 16.9 squared add 19 squared minus 2 times 16 times 19 times the cosine of 71.906. We work that out in our calculator. It comes to 428.169. Square root that, and that gives us that DE is 20.692. The question asks us for it to 3 significant figures. So that's going to be 20.7 correct to 3 significant figures. So that's question 16. Really nice question. Could just as easily come up on an A-level paper, by the way, that question, for those of you who are contemplating A-level. Right, question 17. What's this one all about? Y, it says, is inversely proportional to root x. So let's write that first. So y is proportional to 1 over root x. When a question says inversely proportional, we do it in that way, okay? So that means y is equal to k over root x. So that's our proportionality statement and gone into an equation. Now they're doing something a little bit weird here. They're telling us that when y is equal to c to the power 4, when x is equal to c squared, find the formula in terms of x and c, a formula for y in terms of x and c. So we really ought to sub in the y and x that they give us. So y is c to the 4 and x is c squared. So all I've done is sub in the information from the question. Now the square root of c squared is just c, and then I'm rearranging this to find out what k is by timesing both sides by that c. So that gives me k is equal to c to the power 4 times by c to the 1, which is going to be c to the power 5. And that's it. So we just now say that, okay, we found out that k is equal to c to the power 5. So we just replace that in the formula, and that's the answer to that question. A little unusual, I grant you, but that's what they've done. Next one, question 18. Nice little bit of functions now. Question 18. Okay, what have we got here? It says the function f of x is such that f of x is equal to k over x, where x is not equal to 0 and k is an integer. Find the inverse function f to the minus 1 of x in the form f to the minus 1 of x equals. Now, let's think about, it's only worth 1 mark, but let's think about what our steps are for finding an inverse function. So step 1 is we write down f of x as y is equal to k over x. Now, there's different ways that teachers explain this, but I'm going to go with the swap x and y method. So we swap over the x and y, which means wherever you see a y written, you change it into an x, and wherever you see an x written, you change it into a y. Okay, so that's what I've done. I've changed a y into an x and an x into a y. Then once you've done that, you need to rearrange it to make y the subject. So I've multiplied both sides by y. So I write here times by y. And that gives me xy equals k. And then I just divided by x because I'm trying to make y the subject. So divided by x, and I find out that I get y is equal to k over x. So that means the inverse function f to the minus 1 of x is k over x. And you'll notice that that's exactly the same as the original function, okay? We give this a special name. It's actually called self-inverse. So it's a self-inverse function, okay? You don't worry too much about knowing that it's called self-inverse, but we end up with the same thing when we do the inverse. Okay, question B, it says the function g is such that g of x is equal to 2 minus 3x to the 4th, and we have the function h of x is equal to 3x over 2 minus x. Find out what is g of minus 2. So g of minus 2, we're going to put minus 2 into our function. So g of minus 2 is going to be 2 minus 3 times by minus 2 to the 4th. Minus 2 to the power 4 is 16. And then we have 2 minus 3 times 16 is minus 46. So that is B part 1. And then B part 2, it says express the composite function h of g in the form h of g of x equals, giving your answer in its simplest form. So I've written down h of g of x equals. Now, I really like thinking about composite functions in this way. So g of x is going inside h of x. So I like to write h of x with g of x in the brackets. That's what I think is the most useful for thinking about this way. Okay, so there we go. We have h of open bracket 2 minus 3x to the 4th, which is g of x. Now, This is your new x. So what you do now is you write down the h of x function, but everywhere there was an x in h of x, you replace it with that. So we've got 3 times by 2 minus 3x to the fourth over 2 minus 2 minus 3x to the fourth, okay? So that is your new x. And you write down h of x, but everywhere that there was an x, you replace it with that. Okay, so now we just got to simplify this function now. So now, in order to simplify this function, we're just going to expand the numerator. So 3 times by 2 is going to be 6. 3 times by 3 is going to be 9. Okay, so that's those two. And then in the denominator, when I remove the brackets, I get 2 minus 2. And these two minuses come together to make a plus. So that is plus 3x to the fourth. Let's collect our like terms there. So 2 minus 2 is nothing. So the denominator is just 3x to the fourth. And the numerator is 6 minus 9x to the fourth. We've got a common factor of 3 in every single term. So we can divide the numerator and denominator by 3, giving us 2 minus 3x to the fourth over x to the fourth. And that's our final answer for 18 part 2. All right, next question. Really important question, this one. Really important bounds question. So this is super useful bounds question, okay? Very important one, and a good question, this one. How many marks? 5 marks, really nice. I'd say great, solid grade 8 question at least. The acceleration a of an object is given by a is equal to v minus u over t, where v is equal to 45.23, u is equal to 5.12, and t is equal to 8.5. Okay, so it says by considering bounds, work out the value of a to a suitable degree of accuracy. I cannot emphasize enough how important that statement is right there. Suitable degree of accuracy. That's super important, okay? So when they ask you to do this, suitable degree of accuracy, quote unquote, what you've got to do is work out the upper bound and the lower bound of A, and then see to which extent they agree with each other. So first of all, the way to start this question is by writing out the upper bounds and lower bounds of all of the individual components. So V rather, is 45.23, correct to 2 decimal places. So the upper bound is going to be 45.235. The lower bound is going to be 45.225. So there's my upper and lower bound. For U, we've got 5.12, correct to 2 decimal places. So my upper bound is going to be 5.125, and my lower bound is going to be 5.115. Okay, and then we've got T is equal to 8.5, so our upper bound is going to be 8.55, and our lower bound is going to be 8.451. No, 8.45, sorry, that's a bracket. Okay, now let's think about this. Now, when you've got a quotient, when you're dividing and you want to find an upper bound, you need to have the biggest thing in the numerator and the smallest thing in the denominator. And the thing that helped me to remember that is when you divide by a small number, you get a bigger number. So that's how we know that we need to have, for an upper bound, when you've got a fraction, you need to have the smallest thing in the denominator and the biggest thing in the numerator. Okay, so that's the first thing. And you'll notice that in the numerator, we've got two things taken away from each other. We've got v minus u. Now, when you're taking two things away from each other, in order to get an upper bound, you need to have the upper bound of the first number take away the lower bound of the second number. That's how you're going to get an upper bound for that gap. So if we need an upper bound of v minus u, that means we need an upper bound for v minus the lower bound for u. So we're going to have the upper bound for v, which is 45.235, take away the lower bound, okay? So we have 45.235 minus our lower bound, which is our 5.115. So that's how we get an upper bound take away lower bound. And we need to divide that by the smallest bound of t, the lower bound for t, and that gives us 4.7479. So that's the upper bound for A. Okay, a little bit confusing, I know. Now we've got to work out the lower bound for A. Now, when you want a lower bound of a fraction, you need the biggest thing in the denominator and the smallest thing in the numerator. But remember, our numerator is v minus u, so we want that gap to be as small as possible. And when you want that gap to be as small as possible, what you need is the lower bound of the first number and the upper bound of the second number. So we need to use the lower bound this time of v, and we're going to take it away from the upper bound of u. And the lower bound of v was 45.225, so there's our lower bound, and our upper bound for u was 5.125, so 5.125. And then the denominator, we want the upper bound for t, and the upper bound for t was 8.55. So we work that out, and that gives us 4.6900. So that is our lower bound for A. So we've got our upper bound and our lower bound. Now, this is the bit that I was talking about, the quote-unquote suitable degree of accuracy. So you look at these two numbers and you say to yourself, okay, what's the greatest degree of accuracy that they both agree with each other to? Do they agree with each other to 3 significant figures? So that would be 4.75. What would this one be? 4.69. So they don't agree with each other to 3 significant figures. So then you try. So let's write down here 3 significant figures. They don't agree with each other. So now let's try 2 significant figures. To 2 significant figures, this one would be 4.7. And this one would be 4.7 because that 9 would round up to a 7. So they do agree with each other to 2 significant figures. So that's what we're going to go with. So the suitable degree of accuracy is 4.7. So it's as accurate as possible where they both agree with each other. They didn't agree with each other to 3 significant figures. They did when we got to 2 significant figures. So the correct answer is 4.7 there. I think that is the end of question 19. Really important question. 5 really good marks. I think quite nice, nice one to understand there. Okay, that's it. And question 20 has been done in a previous video. So I hope you found that helpful, and I will see you in the next video.